Hello everyone. Welcome back from Easter break. I hope you all had a great Easter. So now we are going to get into the remaining bit of chapter 10, and I am going to go through section 10.6, which is counting principles, permutations, and combinations. This is kind of your introduction to probability and looking at the methods for finding possible outcomes. Okay, so if you want to figure out how many possible ways a race could end with people in first, second, third, and so on and so forth. Or how many different ways I could pick 5 people from the class to have no homework. That's not happening. But these are the ways in which we could do that. So our success criteria, I can confidently use the fundamental counting principle. That's going to be in examples 1 through 3. I can calculate permutations, which is 4 and 5. I'm able to distinguish the difference between permutation problems and combination problems, and I can calculate combinations. Now, combinations you've already seen before, and when we get to that, you'll know what I'm talking about. So, the fundamental counting principle, basically what that is you're trying to figure out the number of ways in which a series of successive things can occur, all right? And the way you're going to do that is by multiplying the number of ways in which each thing can occur. Okay, so here's a little example. You probably did this in elementary school, but a little throwback. You wake up and you have to select something to wear out. You only have 2 pairs of jeans, 3 t-shirts, and 2 pairs of sneakers. Let's imagine. How many possible outfits could I have for that day? All right, so we gotta think for jeans, we'll make jeans a J. We have 2. T-shirts, we have 3. And sneakers, we have 2, right? Now, what you did in elementary school was you made this little tree diagram. So this little person, right? So first thing I need to select is jeans, right? So I can have either the first pair of jeans or the second pair of jeans to wear, right? Then from the pair of jeans, then I can figure out, all right, how many T's? 3 T's. If I pick the first pair of jeans, I can have either t-shirt 1, t-shirt 2, or t-shirt 3. And that's same if I pick jeans, the second pair of jeans. Okay? It's not like because I wore the blue jeans, I can't wear certain shirts. Okay? And then last are sneakers. So I can wear either sneaker 1 or sneaker 2 for any one of these possible outfits, right? Think of your outcomes as like paths in which you could take. How many different paths can you get to getting dressed? So everything can have sneaker 1 and sneaker 2. Now, how many possible paths you can have is how many En-ROADS you have. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12 different paths in which you can take to get dressed. So you have 12 possible outfits. Now, it's not always going to be this easy where you have like 2 and 3 and stuff like that types of outcomes. You may have like 8 possible shirts and 5 pairs of jeans and all these things, and it would be really hard to make this tree all the time. So if you use the fundamental counting principle, all you would have to do instead of the tree you will multiply all outcomes for each selection. Okay? So in this case, I need to pick jeans, and I need to pick a t-shirt, and I need to pick a pair of sneakers, right? Well, the word and in probability means to multiply. So we have 2 pairs of jeans and 3 t-shirts, 2 pairs of sneakers that we could choose from. 2 times 3 is 6, times 2 is 12 possible outfits. Okay? This will work every time, and it saves you all that time drawing that trait. So, how can we use it here? Next semester, you were planning to take 3 courses, Math, English, and Humanities. Based on the time blocks and preferences of teachers, there are 8 sections of Math, 5 of English, and 4 of Humanities that you find suitable. Assuming there are no schedule conflicts, meaning one English class is being held at the same time as another Humanities course. How many different 3-course schedules are possible? So, we have Math and English and Humanities. So we have 8 sections of Math, 5 of English, and 4 Humanities. So what I'm going to do is I'm going to multiply all of these. 8 times 5 is 40, times 4 is 160 different 3-course schedules. Oh my goodness. All you have to do is multiply. Now you're going to try this next problem. Okay, all problems you solve on Edpuzzle will be explained in the next class, so make sure to bring your notes on that. So, example 2, multiple choice test. You are taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices with 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, how many ways can you answer these questions? So they just asked not what's your chances of passing. Okay, that's kind of the next step that you'll do in your actual statistics course. But if we want to know how many ways can you answer all 10 questions, all right, we got to think, well, for each question, right, for all 10 questions, all of them have the same amount of outcomes, right? 4 answer choices. So you got to think in terms of question 1, 4 options to pick from, right? And then you have to answer question 2, which has 4 options. Remember, and means multiply. And you have to answer question 3, which has 4 options. And you have to pick the 4th and the 5th, and so on and so forth, right? So basically, you're multiplying 4 by itself ten times, right? Because you have 10 questions, and all 10 questions have 4 choices. So this is how many possible ways you can answer this test. So 4 to the 10th power, what you're going to get is 1,048,576 possible ways to answer the questions. Okay? So you have 4 possible ways of answering this test if you just out of nowhere just pick 10 questions. Okay? Now, why would this be helpful? Well, let's say you didn't study and you're just going to wing it. Okay? So, basically, you know now there are over 1 million possible ways you could answer this test, but you want a perfect score. So the way you're going to use this is you're going to do, well, what's the probability of getting a perfect score? Well, how many of these outcomes are a perfect score? Only 1. So 1 out of 1,048,576. Those are your chances of perfectly guessing a perfect score. So obviously, it doesn't look good. Is it possible? Yes, but very unlikely. Okay, so that's why we're learning about all this, figuring out our possible ways, so that later on you could take it a step further to figure out, well, what's your probability of getting one of these specific outcomes? Or you just want to pass, how many of them are passing? Okay, so you're going to try this next problem on Edpuzzle. All right, again, remember all Edpuzzle pop-up questions will be answered in class. Now, example number 3, telephone numbers in the U.S. I like this problem. It kind of makes you think about it a little bit. All right, so telephone numbers in the U.S. in the United States begin with a 3-digit area code followed by a 7-digit telephone number. Area codes and local telephone numbers cannot begin with 0 or 1. How many possible phone numbers can we have in the U.S.? So you got to think about a phone number, right? We got our area code, then we have our 3-digit, then 4-digit, right? So here's the area code, and here's the telephone number, right? Well, they said specifically, so we got to think. How many digits? Think of digits, right? 0, 1, 2, 3, all the way to 9, right? Well, we have 10 digits because 1 through 9, and then the number 0. So there's 10 possible numbers that can fall in each category. However, they cannot start, right? Area codes and local telephone numbers cannot begin with 0 or 1. So these are the beginning of the area code and telephone numbers, right? So instead of 10 possible outcomes, since you can't have 0 or 1, you have 8 possible outcomes. But the rest, there are no rules about any of the other ones. So we can have 10, 10. And the reason we can all have 10 for all is because we can have numbers repeat. That's no problem, right? So if you want to figure out how many possible phone numbers we're going to have, you're going to multiply all these numbers together. So we have 2 8s, right? So 8 squared times, we have 1, 2, 3, 4, 5, 6, 7, 8, 10. So times 10, 8 times to the 8th power, right? So when you do this, you are going to get 64 and then 8 zeros. So you can have 6,400,000,000. So 6.4 billion different telephone numbers in the United States. There are about 7 billion people on the planet, so we definitely have more than enough telephone numbers for the U.S. If they feel like we've run out and we need more, that's usually when they start adding a area code, right? You might have seen that before. I know growing up, my area code in my town was 631, but then after I moved here, I know they split up my area code into 2 different ones because it covers so much area, they needed more phone numbers. All right, we're going to do this last one. All right, so now there's a second video on the second half of this, but I just want to keep it short, and then you could do the second one, but make sure get all this stuff done, and let me know if you need any help. Email me, figure out office hours.